Most people walking along London's riverbanks have no idea what's really happening beneath the surface. Every year, tens of millions of tons of untreated sewage are pushed into the River Thames. When heavy rain hits, this historic waterway can transform into something far darker, shocking visitors, endangering wildlife, and exposing a hidden weakness in one of the world's most advanced cities. This crisis wasn't caused by indifference. It was a result of success. London grew faster than its foundations ever anticipated. The sewer network, engineered during the Victorian Age, was once a global marvel. But a system built for a 19th century city was never meant to serve a sprawling modern megacity. By the early 2000s, stormwater overflows were dumping waste into the river almost weekly, suffocating fish populations, degrading water quality, and drawing legal pressure from environmental authorities. A problem this vast demanded solution just as bold. Engineers proposed an underground giant, a new interceptor tunnel stretching beneath the capital. Its role was simple in theory yet monumental in scale. Capture overflow during storms, store enormous volumes of wastewater, and move it safely to treatment plants downstream. It would be both an environmental safeguard and a once-in-a-generation engineering statement, the largest overhaul of London's sewage system in over a century. That vision is now complete. By 2025, the tunnel became fully operational, fundamentally changing how London protects its river. Today, we explore the £6 billion Thames Tideway Tunnel, one of the most ambitious infrastructure projects in modern British history. The story begins long before modern London. In the mid-1800s, the Thames itself had become a channel for raw waste. By the summer of 1858, the smell grew so overpowering that it halted parliamentary business in what became known as a Great Stink. The city was forced to act. The solution came from engineer Sir Joseph Bazalgette. His sweeping sewer system redirected waste away from the river, using more than 1,800 kilometers of underground channels feeding massive interceptor sews. These were reinforced by new embankments that reshaped London's riverfront. Completed in the 1860s, the project helped eliminate cholera outbreaks and laid the groundwork for a healthier city. For generations, that system worked remarkably well. But time caught up. Built for a population of 2 million, it now struggled to serve nearly 9 million people. Expanding concrete landscapes replaced natural drainage, and a combined sewer system, carrying both rainwater and waste, was easily overwhelmed. During heavy storms, overflow outlets spilled directly into the Thames. By the early 21st century, these discharges were releasing up to 40 million tons of polluted water each year. River users recoiled, ecosystems suffered, and regulators demanded urgent reform. Under mounting pressure, Thames Water and the UK government moved toward a permanent fix. To deliver it, a new infrastructure body was formed. From that partnership emerged the Thames Tideway Tunnel, a long-term solution designed to protect the river for decades to come. The tunnel itself is immense. It runs roughly 25 kilometers beneath London, from Acton and the Wester Abbey Mills in the east, passing below some of the city's most historic and densely built neighborhoods. With a diameter wide enough to swallow a double-decker bus, it ranks among the largest wastewater tunnels in Europe. Its depth increases as it moves eastward, ensuring gravity-driven flow while minimizing disruption above ground. Its mission is direct and powerful. Intercept sewage before it reaches the river. 34 of London's most polluting overflow points are now connected to the tunnel through deep shafts and linked tunnels. When storms overwhelm the old system, the waste is diverted underground instead of spilling into the Thames. The tunnel can temporarily store up to 1.6 million cubic meters of wastewater, nearly 600 Olympic-sized swimming pools. Once rainfall subsides, the captured flows are sent onward through the lead tunnel to Beckton Sewage Treatment Works, the largest facility of its kind in Europe. Beyond function, the project has reshaped the riverfront itself. Temporary construction zones are being transformed into new public spaces. The Bazalgette embankment at Blackfriars stands out, the first new riverside embankment in 150 years, reconnecting people with the Thames. Building the tunnel was a feat worthy of its Victorian predecessor. The project was split into western, central, and eastern sections, allowing multiple tunnel boring machines to operate simultaneously. These machines were lowered into enormous shafts, then slowly carved through London clay, chalk, and gravel, installing concrete segments with millimeter precision. Even slight misalignment could have compromised the entire system. Safeguarding historic buildings and underground rail lines required constant monitoring. Construction also extended far beyond tunneling. At 21 connection sites, massive shafts were sunk in some of the city's tightest spaces. At Chambers Wharf, engineers built one of the largest cofferdams ever placed in the Thames, enabling excavation below river level without flooding. Moving millions of tons of excavated material posed another challenge. Instead of flooding City Street with trucks, spoil was carried away by conveyor belts and barges. At peak activity, up to 150 barges a week traveled downriver, eliminating hundreds of daily lorry trips. Nearly all excavated material was transported this way, with much of it reused to create new habitats at Raynham Marshes. By 2022, tunneling was complete. Testing and commissioning followed as sites were connected and systems brought online. In 2024, the final breakthrough to the lead tunnel was achieved. By early 2025, the full system was live, quietly doing what it was built to do during every major storm. The financial story was no less complex. Initial projections placed costs just under £5 billion, with additional preparatory expenses. Pandemic disruptions added further pressure, pushing final costs to between £5.7 and £6.3 billion. To manage this scale, a dedicated company, Tideway, was created as a regulated infrastructure provider, backed by private investors and supported by government guarantees. Rather than funding the project directly, costs are spread over time through modest annual charges on customer bills. The tunnel was officially inaugurated in May 2025, with King Charles III in attendance, marking both the end of a decade-long build and a symbolic continuation of Basil Get's legacy. Criticism was inevitable. Rising costs sparked public concern, especially as households face higher utility bills. Executive pay controversies intensified debate over accountability. Engineers also face immense technical risks, tunneling beneath heritage structures and busy transport networks, while riverside communities endured years of disruption. Environmental groups questioned whether surface-level green solutions could have replaced such a deep tunnel, though experts argue that London's density left few alternatives. Yet the results are already visible. The tunnel captures roughly 95% of the sewage that once flowed into the Thames, reducing overflows to just a handful of days each year, even during intense rainfall. Early operations have already prevented massive pollution events, allowing aquatic life to return and improving safety for river users. Before we wrap up, it's worth zooming out for a moment. Projects like the Thames Tideway Tunnel quietly redefine what a city chooses to value. Most people will never see it, never walk through it, and never think about it on an ordinary day. And that's exactly the point. The greatest infrastructure works disappear into daily life, protecting millions without applause, headlines, or spectacle. In the years ahead, the Thames won't just look cleaner, it will function differently. Fewer emergency closures, fewer ecological collapses after storms, fewer moments where progress collides with neglect. Children growing up along the river may never know what it once carried beneath the surface, and that quiet ignorance may be the tunnel's greatest success. Still, this isn't the end of the story. Climate change will continue to test cities worldwide. Population pressures won't ease. Infrastructure built for the future must be paired with smarter surface drainage, greener streets, and policies that reduce strain before it reaches underground systems. The Tideway Tunnel buys London time, but how that time is used will define the next chapter. For now, the river breathes easier. A problem once hidden, ignored, and tolerated has been confronted head-on deep below the city streets. Expensive, controversial, and complex, yes, but transformative, and maybe that's the most powerful takeaway of all. Cities aren't only defined by their skylines, monuments, or mega projects you can photograph from a distance. They are defined by the systems that work silently every hour of every day, keeping millions of lives moving without disaster. When those systems fail, the damage is immediate. When they succeed, they are almost invisible. The Thames Tideway Tunnel belongs to the invisible class of achievements. It doesn't promise instant spectacle. It promises prevention. It promises that storms no longer mean crisis, that growth no longer guarantees pollution, and that progress doesn't have to come at the river's expense. 150 years ago, Victorian engineers solved a public health catastrophe with brick, ambition, and bold thinking. Today's engineers face a different challenge: climate pressure, population density, and environmental accountability, and answered in a way only a modern city could: deep underground, precise, massive, and largely unseen. Years from now, debates over cost will fade. Construction noise will be forgotten. What will remain is a river that functions again as a living system rather than an overflow outlet. Fish returning. Safer waters. A city better prepared for the storms ahead. This is what future-proofing really looks like. Not perfection, not permanence, but resilience. The willingness to invest now so that future generations inherit fewer problems than we did. And beneath London, quietly doing its job, the super saw flows on. If you enjoyed this deep dive into one of the world's most ambitious infrastructure projects, make sure to like the video, subscribe to the channel, and share it with someone who loves engineering, cities, or the stories hidden beneath them. Until next time, thanks for watching.